Hello and welcome to Study Circuit Revision, doing GCSE Edexcel Astronomy, Topic 6, Celestial Observation. This is part 2 of a video that I did about a week ago, and this section will cover the celestial sphere and coordinate system part of Topic 6. First, we're going to start with some recall questions. Pause the video and have a go at them. And here are your answers. Okay, let's talk about cardinal points. There are 4 cardinal points, and these are just the normal points on a compass. North, east, south, and west. You don't really need to know too much about them. You need to know the bearing of them, so north is 0, east is 90, south is 180, and west is 270. But you can probably work that out yourself, to be honest. There are 2 different coordinate systems we talk about in this topic. I'm not going to talk about the terms declination, right ascension, altitude, and azimuth right now, but here you need to know that declination and right ascension are both part of the equatorial coordinate system, and altitude and azimuth are part of the horizon coordinate system. The equatorial coordinate system is more of a system where everything is in a fixed position, so the declination of a star will always be what it is. So say Vega's declination is 70, it will always be 70, and the same for its right ascension. Whereas altitude and azimuth, it can change depending on where you are on the Earth's surface. So let's talk about the celestial sphere. The celestial sphere is an imaginary sphere that surrounds Earth, and this is basically what people in old times map the whole sky onto. So every single thing you can see in the sky is on the celestial sphere. Now, declination is a measure of how high or low an object is on the celestial sphere. So the higher you go, that's positive, and when you go down, that is negative. There are specific points on the celestial sphere you have to know about, and you have to know their specific declinations. That is, these are all easy. The celestial equator, which is the invisible projection of the Earth's equator on the celestial sphere, and the North Celestial Pole and the South Celestial Pole are both imaginary projections of the North Pole and the South Pole on the celestial sphere. Now, there's also a line called the ecliptic, which is on the celestial sphere. This is the imaginary path that the sun takes. So imagine you see the sun go across the sky for today. The path that the sun takes for a whole year can be mapped onto the celestial sphere, and this is called the ecliptic. And now you can see that there's a 23.4, you need to know it's 23.5 degree gap between the ecliptic and celestial equator, and that is how we define the tropics. Now, you also have to know about right ascension. So right ascension is the measure of how far left or right you are on the celestial sphere, and this is measured in hours and minutes and seconds, and this is measured from a point called the first point of Aries, which basically is the time when the ecliptic and the celestial equator cross over on the vernal equinox, which we talked about in previous videos. There's also another point where the celestial sphere and the ecliptic cross over, and this is called the first point of Libra, which is there, but right ascension is measured from the first point of Aries. Now, the horizon coordinate system has altitude and azimuth in, so let's talk about what those are. Altitude is how high an object is in the sky for an observer. So everything on the horizon will be 0 degrees altitude, and anything at your zenith will be 90 degrees altitude. There's also azimuth, which is the degrees an object is away from north. So say an object was directly east of you, the azimuth of that object would be 90. Let's get on to some coordinate system questions. Pause the video and have a go at them. And here are your answers. Okay, culmination and meridian. So you have lots of meridians above you. A meridian is any point where your zenith intersects any line on the earth above you. So imagine you connected east and west with your zenith. That will create a meridian. If you connected southwest and northeast, that will create a meridian. But your local meridian, which is sometimes just called your meridian, is the point of north and south intersecting with your zenith. And this is really important. Culmination is the point at which a star reaches the highest point it will reach in the sky. And culmination will always happen on your local meridian. So say a star has a circle here, the highest point will always be on your local meridian. Now, hour angle and local sidereal time. So local sidereal time, you don't need to know exactly what it is in this topic. You need to be able to use it when you're given it. It's not the exact same as normal time, which you know about and use, but you learn more about it in topic 4. We just use it to do calculations in this topic. Hour angle is the amount of time it has been since your object has culminated. So when an object culminates, its right ascension, so it'll culminate on the southern meridian, its right ascension will equal its will equal the current local sidereal time. So say the current local sidereal time is 11:41, the right ascension of an object culminating will be 11 hours 41 minutes. And to calculate hour angle, this is the time since an object has culminated, it is local sidereal time minus right ascension. I've done a lot of calculations in bold in this video. Those are calculations you need to memorize. They are not given, because the specification assumes that you can work them out yourself, but you need to memorize these ones. Culmination altitude calculation. So you can calculate the altitude at which an object will culminate. There are 2 types of culmination, upper culmination and lower culmination. So this is a star. At upper culmination, you can work out its altitude with the calculation colatitude equals 90. Okay, so colatitude is 90 minus declination. You can work out the altitude of upper transit with coaltitude plus declination. And you can work out the altitude of lower transit with coaltitude minus declination. You need to memorize these calculations as well, obviously. Okay, here are some questions. All of these questions here are linked to the section above. So read that first. Pause the video and have a go at it. And here are your answers. Next, we're going to talk about diurnal motion. Now, this is the motion of stars in the sky. It's called diurnal motion. It's not diurnal motion. Motion isn't a specific kind of motion. It's just the motion of stars. So most stars will rise in the east, rotate anti-clockwise about the north celestial pole, and set in the west. Now that's non-circumpolar stars, which most stars are. Circumpolar stars are stars that will never set. So circumpolar stars, like these ones up here, you can see their paths will never set. The ones closer to the north celestial pole, which is here, whereas stars further out will set. So circumpolar stars will constantly rotate anti-clockwise about the north celestial pole. They will never rise, they will never set. Polaris. So Polaris is the North Star, it is our pole star, and it is used by observers and explorers to calculate their latitude. With this simple calculation here, Polaris calculations are really simple. You do need to memorize this, but it's easy. So the altitude of Polaris will always equal the observer's latitude, and the azimuth of Polaris always equals 0 because it is the North Star, and an azimuth of north is 0. And the declination of Polaris, as it will be an observer's zenith of the North Pole, is 90. So circumpolar stars, you can calculate whether a star is circumpolar with 90 minus declination is less than latitude. So if 90 minus declination is less than latitude, your star is circumpolar. Here are some questions about circumpolarity and Polaris. Pause the video and have a go at them. And here are your answers. Here are some final questions. Pause the video and have a go at them. And here are your answers. Thank you for watching Study Circuit Revision. Make sure to like and subscribe. And our next video on the lunar disk should be coming out very soon.